Alright, this is going to be the review sheet number 27. Quick video. I hope this helps you guys. Okay, first of all, this question right here. Now, this is just an equation, but it might look a little bit different. And basically, what you haven't learned yet, and you're going to learn in 7th grade, I'm just going to do another one that's like number 1 there. And if I gave you something like this, like plus x plus 17 equals 12, okay, or 125, we'll say. I need to make it a little bigger than 12, it'll be negative. Anyway, so there, I just did this one. You can write this if you'd like, but basically, when you draw a line, you all know that you have to be, you all see that there's 24 is being added to x, and then also 17 is being added to x. You know that you got to subtract 17 and 24. I know you guys know that, but what you just got to remember is that commutative, or addition is commutative. So actually, you could rewrite this as 24 plus 17 plus x. And then what you can do, going back to chapter 7, is you can actually, you'll remember this, you can combine like terms. Before you begin the solving process, undoing, you can actually combine these like terms. So I'm going to do 24 plus 17, which is going to give me 41. And then I know that 41 plus x must equal 125. And then from there, now you're going to do the undoing. Minus 41 minus 41, and that's what you're going to get. Okay? So it's kind of this, it's the same process. The only difference is when you have like terms, which I do there and there, I can go ahead and combine those before I begin solving it. Okay? All right. Second one here. Now this, remember, we did one of these last week. This is a 2-step. Now this is the one that I said we're not, this is really a 7th grade thing, but we just like to give you some different things so that you, when you get to 7th grade, you've seen it before. Now I'm going to give you an example. I'm not going to do this one. I'm going to give you an example. So I'm going to make one up. So 3x plus 9 equals 30. I want to pick one that's going to work here. $36. Okay. Now, same, looks very similar. Instead, I used an x, but it looks the exact same. So remember, this is how we would solve this. How we solve a 2-step. You still draw the line. It's called a 2-step because there are 2 things happening to the variable, as you guys know, right? So now we got to do, remember, something called PEMDAS backwards, or reverse PEMDAS, or I've even heard some people call it SADMEP because it's backwards. Basically, you have to undo any addition and subtraction first. You always do it in the reverse order that you would evaluate. Remember, evaluating 3x plus 9 is, you'd follow PEMDAS. When you're solving, you want to undo that. We want to do the opposite of it. So we got to start from where we stopped. Okay? So the first thing you're going to do is you're going to undo any addition or subtraction. The first thing I'm going to do is subtract 9 from both sides. On the left side, that's going to leave me with 3x. Basically eliminated that. And then I know that 3x equals 27. Okay, now it's just a 1-step equation. We know that we need to undo any multiplication or division. So we're going to divide 3. That's going to give me x equaling 9. Then, of course, you guys know, obviously by now, that you always need to plug it in. So now, when I plug it in, I'm going to evaluate 3x plus 9, which is going to become 3 times 9 plus 9. Then I'm going to follow PEMDAS. So they work hand in hand. When you're evaluating or finding the value, you're using PEMDAS. When you're solving for a piece like that, you're going to use reverse PEMDAS. So you're going to get 27 plus 9, which ends up giving you 36, which is what it's supposed to. So that's the work that I expect on that question. All right? Okay, number 2. Okay, this is from chapter 6, all percents. Okay, there's a couple different ways you could do it. First best way is to do a proportion to figure out the tax and the tip. Just remember this, your percent proportion is part over whole equals percent over 100. And you know that your food bill will always be the whole because that's what you're finding the percent of. Okay, and then you know the percent's given, so you're going to have 2 different proportions with that and that. But then you want to know the total bill. So that includes food, tax, and tip, all included. I will be, well, those aren't supposed to be question marks, they're exclamation points. Okay? You need to make sure you're rounding correctly. It will be wrong if you do not round correctly. Number 3. Okay, this is from chapter 6 as well. I believe learning target number 4. Okay, so this is making a strip diagram. Might look a little bit different, but If you read it real carefully, I think you'll understand. Just keep one thing in mind whenever you're doing a strip diagram. The whole point of a bar model of any kind really is to figure out what's one, okay? To figure out one of those, okay? And if you know that 200 of them is 100% of them, then you'll be able to figure it out from there, okay? All right, now I'm going to take a minute on this one, okay? Now, your rules for multiplying and dividing integers. Once again, this is another one of these 7th grade skills, okay? This is a 7th grade thing, but we want to start giving it to you now so you've seen it and it won't be brand new next year. Okay, when you're multiplying and dividing integers, which are just positive or negative whole numbers, okay, you just do the regular problem. I mean, like you just, when you're trying to figure out if it's what, like 7 times 4 is going to be 28, 12 divided by 6 is 2, 5 times 6 is 30, 3 times 5 is 15, 20 divided by 20 is 1. Now, those aren't the answers, but you just do the regular problem, okay? Now, what makes it negative or positive, what makes the answer negative or positive are what are called your integer multiplication and division rules. And basically, these rules are pretty easy. Anytime you're multiplying numbers with the same sign, so that's a positive times a positive, it's going to result in a positive, obviously. When you do 5 times 8, you get positive 40, right? That's an easy one, okay? When you do negative times a negative, that's also going to equal a positive. So it doesn't matter whether it's 5 times 8 or negative 5 times negative 8, it's going to result in 40, which might be confusing. You'll learn more about that next year. Right now, let's just start knowing the rules, okay? Anytime the sign is the same, when I say sign, I mean positive or negative, whenever that's the same, it's always going to result in a positive answer, okay? Whoops. Okay, whereas if the signs are different, so for instance, if I were doing a negative times a positive, that's going to result in a negative, okay? So if I was doing negative 5 times positive 8, that's going to give me negative 40. And same goes for if I'm doing a positive times a negative, that's going to result in a negative as well. So if I did 5 times negative 8, then that is going to result in a negative 40 as well. Okay? Now, these same rules, they apply to division as well. So it doesn't matter whether that right there is a multiplication sign or a division sign. That doesn't matter. So it could be a positive divided by a negative, or a positive times a negative, or a negative times a positive, or a negative divided by a positive. Okay? It's always going to result in a negative. So when the signs are different, the answer is negative. When the signs are the same, a positive times a positive, it's always going to be a positive. A negative times a negative is going to be a positive as well. Okay, so there's your rounding rules. Okay? Now for adding the integers, I'm going to let you guys think about that a little bit. Just think, if you have 5 and you add negative 3 to it, what would that give you? I'm going to let you guys think about those. Okay, now it says you may use a calculator to check. Okay, it's very important that we don't just type them in. I'll be very disappointed. I want to see what you guys know. Okay? Down here, a couple different ways you could do this. Very similar to the one number 2 up here. You could have used, well, I started this one, I think I quit talking about it. But when you said you could use a proportion, absolutely you could use 2 proportions. Or you could just figure out what 6.5% of 4950 is. That's the other way you could do it. Okay? So on these, if you wanted to do that percent proportion, you could, or you could just do 30% of 50. So if you need to look back to your chapter 6 notes, I believe it was learning target number, I want to say 5, I think. Okay, so but either way, just look back in that. Prime factorization, going all the way back to chapter 1. Okay, doing your factor trees. I don't think I need to talk about it because we've done about 1 billion of these throughout the year. This question right here. Find the volume of the following shape. So you guys I'm going to teach you a little bit different of a formula. You guys learned that it's volume equals length times width times height, and that's going to give you the correct volume. Okay, so when you do that, you'll figure that out. The real importance here is correct units. So you got to be real careful. I'm not going to give it to you because I just give you the answer if I told you what the units were. But you haven't learned this yet. But you could always, you could think about it. And you did it in science class. you got to remember, when you have centimeters, when it's area, when we're talking about area, we know that's centimeters squared. Volume's a little different, so I'm not going to say any more. I want you guys to really think about that. All right? Here, what I'm going to give you here is I'm going to tell you the formula. The area formula for this triangle is not base times height. That is a rectangle. That would be this rectangle right here. If that were actually not shaded in there, let me just do this. If this right here wasn't there, it would be a rectangle. And yes, the area formula for that would absolutely be base times height. But as you can see, I'll put it back in, it's half of that. Okay? Which is why the area formula for a triangle is, it's 1/2 times base times height. Okay? So you can use an equation here. You could make this into an equation. So you know that the area is 99. You know that 1/2 goes here, and then you know the base is 9, and then it's h. Okay, and then you can solve it from here. Just keep in mind that right here you can do that. Like, you can do that problem, 1/2 times 9, and then solve it from there. But just think about it. Just understand that that is the formula for a triangle. It's not base times height. So the answer that a lot of people are getting, they're doing it based off of area equals base times height. It's not. It's 1/2 times base times height. Okay? Here, certainly need to work on this one. Okay? You're just using the substitution property to take these fractions and plug them in. So the first step, you must do the first step. You must rewrite that as a numeric expression, and if you don't, it will be wrong. Okay? So you have to do that. This one here, we've done PEMDAS questions for a while. You should have 4 lines, at least 4 lines. So you should have 4 or more. Okay? Some people get 5 when they do it, which is fine. But you should have at least 4. If you have less than 4, you're going to get it wrong. Okay? Here, statistical questions. Remember, a statistical question is a question that where you're going to get multiple answers from it. You're going to have multiple numbers from it. For instance, as I've given you kind of some hints on the last couple review sheets when we've done this, a statistical question. If I said, how many dogs does everybody that I teach have? I would go around my class and I would say, how many dogs do you have? One person said 2. One person said 3. 1, 1, 2. That is a statistical question because I'm getting several different answers. Okay? Whereas if I went up to one student and said, how many dogs do you have? Like, you went up to Josh and said, hey Josh, how many dogs do you have? He would say 4. That is not a statistical question because I'm not getting a bunch of answers after that. Okay? Let's go to the back. Okay. Here, we're using the distributive property. Okay? So I'm going to let you kind of think about this one, but you should know that the distributive properties, when you multiply the number through, make sure you do it to both terms. Okay? And then this is going to be kind of trial by error here to figure out which one of these would actually equal whatever that gives you. So just using the distributive property, just try it. Here you are certainly going to need work. Okay? This is going to go back to the same exact question that we did on number 1. And I'll flip back in a minute. But the number 1 where you had to solve that equation right there, and you had to show all the work, the 2 steps, that's what I'm requiring now. You know how to do it, so you need to show this here. You would need to draw a line, and if you're on this and you don't know how to solve it, rewind the video to the beginning because I did one exactly like this. Very similar. Okay? If you just go through and simply say, I'm just going to take 5 and plug it in. I'm going to take 14 and plug it in. I'm going to take 16 and plug it in. See which one will be true? I'm going to count it wrong, guys. I want you practicing this skill. Okay? Not looking at the answer, because let's face it, what if I would have given you the question like this? Then you would have to solve it this way. Okay? So I do not want you just plugging in. I want you solving it, showing all the 2 steps, the undoing, the inverses, all that stuff. Okay? Here we're doing the sum. What is the sum of that and that? Elementary stuff right there. So just make sure you obviously need work here. You can check with a calculator, but your work must match. Next page. Okay. This is showing the visitors, 20 visitors' ages at a library. Just kind of kept track in a little chart. So you can see there was a 15-year-old that came in, a 27, a 53, and so on. Okay. and you have to pick which histogram. Now remember, a histogram is one that instead of having categories like a bar graph would, like if I was doing my favorite ice cream and you had like chocolate, vanilla, mint chocolate chip, whatever, and you had all these different types of ice creams here, that would be a bar graph. Okay, this is not a bar graph. Also, the bars in a bar graph are not touching. They would look more like this, with a space in between all of them. Okay? This is a histogram. And basically it gives you a range. So it gives you the amount of people from 0 years old to 9 years old. This particular one here, this graph, letter A, it's saying that there are 4 people from 0 to 9 years old. It's saying there are 7 people from 10 to 19. There are 3 people from 20 to 29. There are 2 people there. There weren't any from 40 to 49. And then there were 4 people in that range. So you're just going to have to go up here and, more or less, you're going to have to go through and say, maybe use colors and maybe say, okay, I'm going to figure out how many people up here are between 0 and 9 years old. So that's what you look at. And you say, okay, you go up here and say, okay, between 0 and 9, okay, I see 1, I see 2, 3, 4, 5. So right away, I've eliminated A for you because I know there are 5. It should have been to there. So A is eliminated, okay? Now, that might not be the only one that helps you. There probably are going to be a couple that have 5. Actually, all the rest of them have 5. So now you're going to have to go to the next range and go to 10 to 19 and figure out how many of those there are, okay? So pretty easy there, I think, okay? And finally, you have to have a proportion here, okay? It's a percent. You actually can do a strip diagram here. If you did it, you could do a proportion or a strip, I guess I could say. You could do a strip diagram, absolutely. Proportion probably be a little quicker, but anyway, whatever you feel comfortable with, or both, that would probably be the best. That is what you're going to do there. And then down here, you're going to have to use kind of the information from up there. And once again, you can do a proportion or a strip diagram on that. Okay, but I don't foresee any problems there. On your proportion, just make sure you have labels. Okay? All right, guys. I hope this helped you out.